We have with us Kevin Wood, who is a robotics enthusiast. Hey, Kevin, thanks for joining.
Hey, Devin, thanks for inviting me.
Yes, so I would let you briefly introduce yourself to the audience.
Yeah, so my name's Kevin. I've been doing robotics and AI for the past 10 years. Initially, I was focused on mechanical design, but then the recent past 5 years, I've been more focused on AI and computer vision. But, I enjoy the whole aspects of robotics from design to, the software simulation, all of that. And right now I have a YouTube channel with 40,000 subscribers. So trying to share my knowledge with the rest of the world.
So, more recently on your YouTube channel, you've also done deep dives into humanoid robots, especially the mechanical aspects of the design of the humanoid robots. So, in this episode, I wanted to maybe get your impressions on the latest news and latest unveilings that has happened in the humanoid robotic space.
Yeah, so let's take a look.
So, before we jump into that, I just wanted to get a general sense from you about what you think about the humanoid robotics right now. There are probably maybe more than 50 humanoid robotics hardware companies, and the companies that are doing AI are all of them are open-ended research projects. So do you see, what's your sense on when will we see viable product that is general purpose in humanoid robots?
Yeah, that's a really good question because like you said, we've been seeing a lot of companies. It's been almost every week that we see a new humanoid robot from, especially Chinese companies lately. They've been having a lot of news with their new designs and updates. But definitely right now, I would say the biggest challenge in general purpose robots is data. So I think a lot of people, they seem to be very good at the mechanical side of things because we see the robots built and some moving better than the other. But the real bottleneck right now is we haven't really seen too much robots do meaningful tasks. There has been some demos like from Figure, they say this autonomous, but we've seen some from NEO too, which has been teleoperated. But I think their path is trying to collect more data. But just
Right.
looking at how ChatGPT has developed, I think considering how much data that ChatGPT is off of, since it's the entire internet, all that data on the internet, you kind of want to compare it to that amount of data for this general purpose autonomy to be solved. So that's kind of how I view it. I think once they get to that level of data, I could see them getting closer and closer to full autonomy. So I feel like the timeline, I would say, might be somewhere between like 5 to 10 years, at least 5. But we may be surprised if, for example, if NVIDIA really solves, they've been working a lot on creating simulated data. So if they're able to really unlock that simulated data and accelerate that speed in utilizing the simulated data to really make it meaningful for the robot to learn off of, then that timeline might shrink down to, maybe even 3 years. So very curious to see how they're able to execute on that. And, Tesla has been the leader in, not only do they produce cars, produce robots, but they truly understand AI to the core because how they're developing Grok and FSD. So I think it really takes a company like that to, understand hardware and software, the whole full stack of their system to deploy. So yeah, I'm very excited for the future. And I think, solving this AI problem that Tesla is doing, how they're trying to understand Grok I think is the way to go to solve general purpose robots.
Yeah, it's interesting that Elon's performance package has 1 million Optimus robots as a goal, and his compensation package got approved. So is it going to accelerate the Optimus program, you think?
I definitely think so, because with more money, there could be more talent, and I think definitely more incentive to keep pushing forward. So there's been a period of time where people were very scared and concerned about Elon focusing too much on politics. But I think with this package that has been approved, I think it definitely puts Elon on the focus of, putting it all on Tesla. And like he said, he may have to pull some magic rabbits pull some rabbits out of his magic hat. So we'll see what tricks he can pull out of his sleeves.
Yeah, did you see the Texas? They've already started clearing ground for supposed Optimus factory, which is going to produce 10 million robots.
Yeah, that's pretty
So
impressive.
yeah, we'll
Yeah, because
see. Like that sounds like an ambitious goal for 10
yeah,
million,
definitely.
maybe.
But I think once they
Yeah,
have all the robots deployed, they could also use that to collect more data and make their systems better. It's the same pattern that they have with FSD. They have the Tesla cars that have been out for years before FSD was solved. So I think a lot of robot companies are following that same approach where they're like, okay, let's get the hardware out first. It's okay if it's not autonomous yet. But once they have the hardware out and people adopt to their hardware, it's all about who adopts first, right? Because if, let's say, someone likes Unitree more, or someone likes Optimus more, or someone likes Figure more, it's all about the adoption, right? Once someone likes the public image or the robot, whatever it is that they like about that robot, then the
right.
adoption of that is what's going to matter.
Okay, so let's get into the news from maybe last 3 or 4 weeks. The most recent one and most interesting one, I think, was the Xpeng next generation iron robot, which kind of created waves on the internet because of how real the robot looks. And I got a lot of comments saying that this is definitely a person in a suit. What were your impressions from the design?
Yeah, I mean, their walking is definitely very realistic. So I definitely wouldn't blame people for thinking that, that people suspected it being fake. But in terms of the design, I would say it looks very similar to Tesla Optimus design. If you look at some of the inside of the skin, you could see some of the actuators, how they look. So some of the configurations of the joints, you can see that they have the linear actuators for the thighs as well as the calves. And also in the forearms, they also have some of the linear actuators that Tesla uses. So there's definitely a lot of similarities. And also in terms of the configurations for the joints, you can see that the hip, they also have pitch last, but they have a roll joint first and then yaw. But I think if you look at Optimus, I think they opted for yaw first, if I remember correctly. But they're all very similar in that they have the pitch last. If you look at the two, some people call it like the Chinese Tesla. A lot of people have been calling it that. I think mostly because of the similarities that we see in terms of the joint configurations and having the linear actuators.
Right. And the CEO on stage presentation mentioned the spine. They have like actuated spine. Did you notice any changes in the waist actuators?
You mean from the previous generation, or?
Yeah,
I think for this one, you could kind of see it. It's a little bit hard to see because it's so cluttered. So in terms of the differences, yeah, I didn't get to analyze that too much. But in some of the presentations, not sure if you have that up, but they have some of the linkages that seems to be a coupled motion. Yeah, I think here you can see the two seems to be a coupled motion, kind of like a universal joint. So that's kind of how they're able to do the twisting motion for the waist.
Right. And then there was this a bit scary looking video.
Yeah, this one is definitely kind of weird to look at. They probably just put a lot of padding in there. It's kind of like, you see people in clothing stores, they're like, we love all shape and sizes. I feel like that's kind of the message that they're shooting for, is to, the robot doesn't have to look a certain way.
Right. And they call this muscles, but it's not really muscles in the sense it's doing anything, right?
Yeah, I don't think it is.
Just for aesthetics.
Yeah.
Right. Let's move on to 1X news, which was also a big news because finally we have a robot that people can order. Although the deliveries are going to start next year.
Mm-hmm.
Are you going to order, Kevin?
Yeah, I thought about it, but I held off on ordering. Did you make an order?
I made an order for the monthly subscription.
Oh, nice.
Yeah. But I have kids, so I don't know when they will feel comfortable enough to deliver a robot to me.
Oh, I know, right?
We'll see. Yeah. So, but there was this interesting video with the 1X launch. where they are showing some guts of the robot that we have not seen before. And it seems like the whole robot is tendon driven, or is it, what exactly this picture shows, do you
Yeah,
think?
I think this part that is showing, I believe it's probably the wrist mechanism. So it has like a sort of differential cable driven mechanism where you can see some of the pulleys are redirecting and then some are active. So this the way the cable is routed allows you to have the wrist, have the 2 degrees of freedom, pitch and roll. So, or depending on how sometimes they call it pitch and yaw for the wrist, but basically it's a 2 axis to allow your wrist to pivot. But a lot of the main focus is to have the extremities, your limb extremities that's like further away from you to be cable driven, mostly to reduce the inertia and try to keep the actuators closer to the joints, the main joints like the shoulder or towards the bicep to really reduce that inertia. And some of the talks that the CEO had from 1X is their main focus is to really cut down on the weight. And the reason being is their main focus is actually about, in case the robot falls on someone, they don't want it to hurt someone a lot. So that's one of their main motivation for making the robot lighter. It's funny because actually in the past, most people would say they try to make the robot lighter because they want the robot to have, in terms of like power consumption or like torque requirements, but he speaks it more in terms of like a safety prevention that most people haven't really talked about.
Right. And they sent Neo to one of the Wall Street Journal person, and this one in this video, Neo took a long time to do these chores, and yeah, here.
Yeah, I think overall this move to put something away in the dishwasher, I think they recorded it to be 4 minutes. And I think it was also even
4 minutes.
teleoperated, right? Yeah, 4 minutes something. Yeah, 4 minute 56. So
Right.
it's definitely in practice, yeah. There's a lot of arguments about is the demo fake because it's been teleoperated. But really, I think their approach is like we mentioned earlier in the podcast, they're trying to bring the hardware out, make people adopt to it, worry about collecting data later, and then try to optimize the system and make it smarter and better in the future. So that's kind of the approach
Right.
that they're taking. And having the pre-orders out, I think from a marketing standpoint is a very smart move because you want to make sure the audience is displaying demand before you put a lot of money into it. So it's pretty smart of them to have the pre-order going on so they know if their time is worth it.
Right.
But if you look at some of
And
the leg design for this robot, you could tell I don't think there's been any there hasn't been any reveal of the actual mechanisms under the suit. I think everywhere you've seen Neo, it has been pretty fully covered. But you could
right.
see by the way it's bending its hips, like how low the thigh is pivoting relative to the hips. It tells me that it's probably a pitch actuation last sort of configuration. So
Okay.
that would be my guess from looking at that. And also the degrees of freedom of the hips, you can most likely tell it has most likely all 3 degrees of freedom. Just the configuration is probably something like a roll yaw pitch or a yaw roll pitch. So it's one of the 2 configurations. They definitely have a knee pitch actuation, and for the ankles, most likely they have the roll and pitch actuation too.
Right. And it the robot was a bit shaky in getting up. Is that because of the algorithm, or do you think there is something inherent to the hardware?
Yeah, I think the shaking could be some of the issues with RL because I know this is being teleoperated, but then there also might be some like full body control to try to stabilize it. I'm not exactly sure how they implement it, but a lot of times when people run RL algorithms, there's stability issues, whether it's the frequency you're running or how you convert your actions to torque commands. So depending on their exact implementation, there could be a combination of either the user is inducing some shaking, maybe because, they're controlling with joysticks and all that. So there could be some delay or lag, or they're trying to find the right pose for the hand. Or it could also be a combination of like the actual commands that they're sending it and how the algorithm is interpreting the command. So without looking into more details of their implementation, those would like be my two areas of guesses what might be causing that.
Right. And we saw this figure 3 robot doing it quite smoothly in contrast to 1X Neo, right?
Yeah, yeah, definitely these are a lot smoother, and I'm not sure. I'm pretty sure they probably had something that was like the perfect shot. I don't think this was teleoperated. I don't think they set that. At least I don't think I heard from anywhere. So it's probably been pretty optimized for these specific movements. Whereas the one we saw in 1X, it was teleoperated. So I don't think it was like a fully reliant on RL algorithm. Whereas it's probably a
Right.
combination of two. So
This is another one example of bending down from Limix. This is the OG Atlas doing it effortlessly, and the new electric Atlas. So yeah, there was a new robot from Unitree called H2. Well, it's probably the tallest robots of all the humanoids. It's 5'11", and a lot of design aspects looks similar to Unitree G1, right?
Mhm.
Did you notice anything interesting?
I think one of the main things that they presented with this robot, I think that everyone talked about, is the face of this robot. They came with the bionic face, whereas most of the other ones that we've seen has just like a typical screen. And for me, I think, in terms of functionality, I don't think there's a real purpose of the function for this. Rather, I think, it's probably one of the first robots to have like a realistic human looking face, which, essentially, if you're able to eventually make the, eyes and mouth actuate, then it'll become, even more realistic. But I think right now, in terms of this, I think it's mostly more of like a marketing standpoint, because typically when you have something that's scary, which I think the bionic face has really been scary to the public, it really attracts a lot of attention. So there's really not much functionality to that. But in terms of the physical design, you could see that the hip right here, you could see they've opted for an angled approach. And
Right.
some of the older Unitree designs, like the G1, they have the pitch actuation, exactly horizontal. But this design, if you pivot it down, I think it can really allow you to have a bigger robot and a narrower hip design, because it's angled. So you're not forced
Right.
to push your actuators out very wide. Because if you look at some of the other H1 Unitree, the bigger ones, they're
Right.
pretty wide and bulky if you look at like
Hmm.
the design of that. So they definitely were able to slim this robot down a lot and really make it look like a human figure and not like a bulky robot that we're used to seeing in their older designs.
It's the first Unitree robot with neck degrees of freedom. You can see in this video.
Yeah, definitely. I think. Yeah, so definitely trying to move towards making, the robot more and more realistic like a human. I wouldn't be surprised if their next step is to actuate some of the face muscles.
Yeah, and they also revealed the price. Right now on the website it says 29,000 for H2, but for EDU the price is not listed. It's probably going to be closer to 50K is my guess for the EDU version.
Yeah, probably. They tend to charge you more with their, open sourcing the SDK and everything.
Right, right. Yeah, that's all I had on the deck.
Okay.
Any thoughts? Any final thoughts?
Um,
You're working on your own humanoid robot design, right?
yeah,
How's that going?
I've been trying to build my own humanoid robot for my channel. So that's why the past couple months I've been studying a lot in terms of the designs and trade-offs of all these actuators and different robots that we see here. But a lot of things that people don't talk about is the actual actuators that go inside. So I don't know, some people might know, but like basically an actuator is something like this, where you have a motor, encoder, a gearbox in there. So there's there's been a lot of talk about the type of actuators that you need to use for robots. In terms of they like to call it the quasi direct drive. So it's basically like a actuator that has low gear ratio, and the reason being is they want the actuators to be able to feel the environment and use that sensing for some torque control when they're trying to do the RL training for the robots to, for example, like walk across the floor or terrain, or even do things like running or dynamic jumping. So, in contrast, if you have like a actuator with like 100-to-1 ratio, typically, because the higher the gear ratio, the harder it is to backdrive. So that's one thing to think about when you're designing, because when it's hard to backdrive and you have a strong impact with the floor, then because it's so hard to backdrive, the first thing that takes a hit is the gearbox, and that would damage the robot, and you might have to repair it. So that's really one of the main reasons why people go with like a lower gear ratio. So a lot of the
Right.
a lot of time spent on my design for my humanoid robot is understanding the layout of the actuators and the configurations of the hips, the arms, and really understanding the trade-offs and comparisons between the different actuators. So that's been a lot of my main focus. And I think also learning about the RL side of things, how to train and deploy robots from simulation to hardware. So once I get all that, I think sometime next year I'll probably have my own robot up and running. So it's kind of the main goal for my channel.
Nice. Like your robotic arm kit, are you planning to have that accessible for others?
Yeah, I think I'm definitely looking into that. Eventually, I want to see if I could, have some version of open source, or I haven't exactly figured out my business model for that yet, but definitely,
Mhm.
something to let the community learn more about how to build their own robots.
Awesome. Yeah. Thank you so much for chatting.
Yeah, definitely. Thanks for having
Well,
me.
I'll put the links for your channel and your website in the description. Thank you so much.
Yeah, thank you.